everyone, Farnaz from iZettle. In the beginning of the day, I was actually wondering why did they put my presentation towards the end? Because usually when I have talks, it's in the beginning because it's quite technical. But now I understand it. Basically, we learned a lot about the strategy, and now hopefully with this presentation, we will also get a chance to go into a real project that tries to apply all of these best models to make a data science project successful. So we'll see. Today, I will talk about a problem we have, or one of the models that I'm part of and we are developing at my company, which is for marketing part of the organization, and it's marketing attribution model, and we call it data-driven marketing attribution model. And we use probability theory and advanced statistics to tackle that problem. Now I will go through each of them and we'll see what do they mean, what is the problem, and how did we actually manage to semi-tackle the problem at hand. The marketing attribution problem, what is that? And then game theory, which is a probability theory, and then a package within Python, Shapley value. How do we use this and how are they connected? The marketing attribution problem. What is the problem? Probably many of you guys know that in the marketing department of any organization, several different, tens of different channels are used to attract new users and do the acquisition of new merchants in our case. But the question at hand is, which of these marketing channels are most responsible to bring our users or new users? Not only that, which one of them is the most responsible to bring the best users, high-value users, that we acquired within this period of time? Many of you, when you want to buy something or purchase a product or service, you do a lot of probably research. You hear about it here and there. You see a Facebook ad, Google ad. You do some research. And we tend to try to collect all of those which are related to our brand and see what is this customer journey before that. And as you can see, assigning the credit to the marketing channel that was responsible to bring that conversion, in our case, that's the problem that we want to try to solve. And the assumption is that we know this journey prior to their acquisition or to the conversion. But the reality is that we actually don't know, and that's why we need advanced statistics to tackle it. Okay, why is it important? Then we can actually, if we can answer that question, which of these marketing channels are responsible for the acquisition of our new users and the conversion, then we can optimize or enhance the return on investment. We can do a better strategic investment, and also we can understand the journey of our customers before they actually come in. Then we do have a better understanding, and then we can serve them even better with our services and products. But what are the common models out there that industry is using? They are twofold: rule-based and algorithmic-based. Usually the industry uses widely and commonly rule-based. Either last touch, which is mostly used in most of the companies out there, that the most credit will be assigned to the last touch point, exactly right before the conversion. What was that marketing channel that you landed in, clicked on, and then landed on our page and became a customer? Position-based, that gives equal credit to the first touch point and the last touch point. I kind of ignore in between. Linear, which is one of the, I would say, the best practices so far that we've been seeing in industry, that just divides equally between all the touch points from the beginning to the end, and time decay. But the data-driven one is the one that we're after, because it shows us the most accurate picture of what has happened really in the middle in the journey, and which one of these channels was the one that was the sweet spot, was the one that gained the trust, and you actually made up your mind and then did the conversion. So we are after that data-driven marketing attribution. We want to build that one. So the advanced statistics we're using is probability theory, game theory, and then the Shapley value within Python. But what is it? How can I explain it easily and simply to you? Game theory is a branch of or applied mathematics that provides tools to analyze and understand different players when they're making decisions that is interdependent. So if you have, and I was at Stanford University 2 weeks ago. I was talking to a team of researchers that they are doing a lot of research on game theory. Game theory is used in, specifically that team, we're using it for politics. And it's used for like any sort of situation that different players are like kind of, making different decisions, that these decisions are actually coming together towards the end. How to make the optimized results out of it. So game theory aims to understand that dynamic, right? So let's, I think I have another slide, but let's imagine that, our marketing channel competition is a game, and these channels are the players, right? The way game theory works, hear me out, is in this way. It comes and isolates each of the players and calculates that player's value. Then calculates all the subsets or possible combinations of this player. So if you have 3, it takes like 1 by each out and calculates it, then 2 of them and all of the possible combinations, who comes first, even the order is important. And then at the end, what it does, it calculates a marginal contribution of each of them with this formula. So if I go back, look at this player A. If I go back, with isolation, player A has value of 7, and with this game theory and formula, now it has 7.7. So it has like another number, credited to that player. So we are after that number, that marginal contribution of each of these players or channels. Okay, good. Now let's imagine that the customer journey is this cooperative game. All of these channels are the players, and they together going to drive the conversion, which is that decision that we want to optimize for, the conversion of becoming our customers. Ooh. Many of us are data practitioners here, right? Statistics is easy. That's like, numbers in mathematics. Data is a challenge, and we all know that. And this project is no exception. The biggest challenge we have is the data part. The data is missing. We have duplicated data. We have a big chunk of data that we don't have we have no clue what's happening, because we only have what we have. In real life, the model that we are trying to build, we have the last touch point data set, right? Because anybody who become a customer, we track it right before, like where did they land eventually, to become our customer. So that last touch point, that's no problem. But what about the rest, right? Where does it start? And we accept the fact, as I mentioned, this project is built on assumptions, and I explained to you how we go about it. So we have to actually assume a lot and extrapolate and come up with the data that is as close to the reality as it gets. We do have an app, so a lot of conversions happens there that is completely isolated to our tracking system. We have Google Analytics that we get the data from. So as you can see, it's like several different databases that we can bring together and make some sort of sense out of what we can work with, and then apply this Shapley value on top of that. Google Analytics by itself has we have a lot of challenge within that database. It's cookie-based, and as you know, many of, especially tech-savvy people tend to clear their cookies time to time. Also, in the business we are at, it's not so much personal. Of course, like majority are like small businesses, but sometimes one computer can be responsible for registering a lot of new merchants if you're sitting at an event, etc., etc. So then one cookie ID is like, bringing in several organization ID, which is not correct. So then for us, the data scientists or the team that we are working on this, is a matter of separating that and like actually making it unique. And a lot more related to the problems that we have, especially like as I said, one cookie ID is like assigned to several organization IDs, vice versa, and you can imagine the rest of the challenges we have with that data. As again, a lot of the data practitioners know, we usually spend 80% of our time working with data and analyzing data and understanding data. And this is one of the graphs that came out of our analysis. And what it says is like, a typical user, most of the time, wakes up one morning, searches iZettle or a card reader, and immediately clicks and becomes a customer. Easy, isn't it? And that's like what data shows us. Is that a reality? Absolutely not. You can't just wake up, especially a service or solution like us. It's not like in a pair of shoes that you wake up and just Google it and buy it. So when we see these sort of data that somebody just searched, landed on the first Google ads and converted, then this shows us and confirm how important it is for us to understand what has happened before that. So to build the model, we need to build the data sets, because the data we have is all over the places, and for this specific problem, we have the need of bringing this data together and creating our own data set. So we started with that as first attempt, building our own data set for this project, combining the tracking system we have plus Google Analytics. And that's the first attempt. I will go on and explain that the problem is much, much bigger than that. But we created the first round of data or data sets, which you can see also gets a bit complex because you need to remove the duplicates or even like multiple repeated data that you have. You need to extrapolate, build those like missing data and make sense of it, and come up with your first data set to apply the model or put it into the model. This comes off again. And something that we realized from analyzing the data is that around 77% of our merchants, we only have one session historic data from them. And that also puts us in a difficult position of not really knowing the combination of different touch points they've gone through. But at the same time, we have a rich data set of arrays of different combinations of touch points that they actually have gone through, which we will use accordingly with our model. And something else that again confirms how important it is to tackle this problem is like 50% of merchants will convert within the same day as they did the first attempt in searching, which again confirms that that's not the reality. Like what has happened before that? You can't just start like doing the first attempt of search and convert. To understand that, it puts this project even in higher importance. And now is the attribution model that we will build on top of that first data set we built, right? What we did and we continue to do is and we built ourselves the last touch model, which is the basic, which like we chose linear, so which is a basic model that anything else we do, we will have this as a base to compare and see how much better we're doing as this data-driven. At the end, we know that this project is high risk and it might not really give us a better answer. And you will see why it's a very challenging project. But then we will have this as a base model, the last touch, and develop our Shapley value on top of our data, and then continuously improving it and continuously compare them. And of course, we do build a model on several different KPIs and metrics we have, from the start to the highest advanced KPI we have. And it's okay, and what we're hoping is to see that the model shows a better result the further along the funnel we go for the highest value metrics. Applying the model on the first data set we built already shows promising results, and it shows that we have seen a shift in the ranking of different channels we had. It's not dramatic, it's not fantastic yet, so we haven't gone out bragging about it yet, as the project still is ongoing, but still we can see the result that this shift has happened, and we can see a promising result coming from the model we are developing. So next step is, so as you can see, is not only improving the model, is improving the data for us. And when I'm saying improving data, is adding any missing data that we can into the data set. And in this case, we included Google Analytics with our tracking data, with the raw Facebook, YouTube, Google Display, and together. And here is the best part, which also touches on a lot of different presentations we've heard today, experts' opinion. We can't really develop anything in isolation as data team. We are heavily working together with the marketing experts, and any assumption we make, we go through them together with each of the channel experts and ask them, does this make sense? If we assume that, especially for Facebook, for example, the data we have is impression-based as much as it's click-based. So we have to make assumptions to use that data, and we wouldn't do it just by numbers and mathematics. We put together marketing experts in loop and just put their feedback back to our data set, which is a really great also confirmation that we have to work together in order to build something that's meaningful for the organization. And of course, there are still a lot of challenges when it comes to building this second or hopefully final data set we have, and all the challenges is especially with the assumptions we make, even though we're trying to tackle it with having experts' opinion, and at the same time we are also not only bringing in different industries projects and the result of them, talking closely with them, how did you solve it, and learning from it. So it's some sort of open innovation approach. And not only in Sweden that I have access to really closely speak with them and understand how did they solve it, but also reading any sort of material on similar solutions and trying to mimic it and see if we can learn closely from best practices out there, since it's a very unique problem. And this is a little view of the Python code and the model we do. So basically what it does, the first one takes all the unique journeys that customers goes through. The second function returns all the possible subsets. So again, if you remember in the beginning when I explained what the game theory does, this is just a code to bring those mathematics stuff into like the coding. Takes all the subsets and then calculates the collision of it, and at the end put all of these together to calculate that marginal contribution and return the final model that can be as close, hopefully, to reality for our data as possible. And again, this works, hopefully will also show really promising result for our case. And it's very unique, it's very case-based, because it's very also data specific. So as you can see, this, if anybody else, and that's open source, you can find it, the code open in the GitHub. But then in order to make this work, it's like to get that data for your organization correct. And with that, I guess I'm done with my presentation ahead of time, I guess. Thank you.